Hello students, today we will do chapter 3rd of NCERT, that is matrices. Now what is a matrix? A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries of the matrix. We denote matrix by capital letters. Now let us understand it with the help of example. Here I have taken two matrices A and B. Now the elements of matrix A are -3, 2, 4, -5, 3 and 6. Now these all the elements are arranged in a rectangular form or rectangular array. Now similarly the elements of matrix B are also arranged in a rectangular form. Now the horizontal lines of elements are said to constitute row of a matrix. Now here if you see matrix A has three horizontal line of components or elements. Now -3 and 2 is the first horizontal line, 4 -5, these two elements make the second horizontal line, and 3 6 make the third horizontal line. That means it has three rows, row 1, row 2 and row 3. Similarly, in matrix B, x square plus 1, 2x and 3x plus 2 make the first horizontal line of this will be row 1. Similarly, this will be row 2 and the last this one will be row 3. Now, the vertical line of components, vertical line of elements make the column of a matrix. Now here -3, 4 and 3 are the first vertical line of elements and this will make column 1. Here 2, -5 and 6 are the second vertical line of elements and it will make column 2. Similarly in matrix B, this is the first vertical line of elements and it will make column 1. It is column 2 and this one is column 3. Thus we can say that the column A has 3 rows and 2 matrix A has 3 rows and 2 columns and matrix B has 3 rows and 3 columns. Now order of a matrix. A matrix having m rows and n columns is called a matrix of order m by n. Now here if we see the matrix A has 3 rows and 2 columns. Its order is 3 by 2. 3 rows and 2 columns. Similarly, a matrix B has 3 rows and 3 columns. So its order will be 3 by 3. Similarly, if a matrix has m rows and n columns, then its order will be m by n. Now, we shall follow the notation, namely A equal to Aij m by n, to indicate that A is a matrix of order m by n. In general, this Aij is the element lying in the ith row and jth column. Now see here, if suppose in matrix A, now this Aij, I am finding A12, A31. Now Aij, I represents the row of a matrix and J represents the column of matrix. That means the first term represents the row and second term represents the column. Now A12 means element of a matrix in first row and second column. Now first row is this one and second column is this one. Now element which is present in first row and second column is 2. So that means A12 is 2. A31 means element of third row and column first, and that is 3. So A31 will be equal to 3. So this Aij represents the element of a matrix in ith row and jth column. Now also, if a matrix has an order m by n, then number of elements in that matrix will be equal to mn. As we see here, in this matrix A, it is of order 3 by 2. So the number of elements in this matrix will be 3 into 2, and that equal to 6. And we can count the number of elements, that is 1, 2, 3, 4, 5, 6. Similarly, in the matrix B is of order 3 by 3. It will have 3 into 3, that is 9 elements. Now, types of matrices. Now, first one is column matrix. A matrix is said to be a column matrix if it has only one column. Now, it may have any number of rows, but if it has only one column, then it is called a column matrix. Now, example is here. I am taking a matrix A. It has elements 0, 2 and 8, and all are arranged in a column. So this matrix has 1, 2, 3 rows and only one column. Therefore, it is a column matrix of order 3 by 1. Now this 3 is row into column. Order of matrix is always row by column. Now in generally, if we write this matrix in general form, then A is equal to Aij, where Aij represents the elements of the matrix and its order is 3 by 1, or we can take it as m by 1. Now number of rows can change. Yeah, it can have any number of rows, but column will be only 1. Now that means a column matrix is always of the order m by 1. Now row matrix, as the name suggests, a matrix is said to be a row matrix if it has only one row. Now here take an example. Matrix B, elements of matrix B are 0 to 8. Now it has only one row. These are arranged in a row and has 3 columns. Therefore, the order of the matrix is 1 row and 3 columns. That means 1 by 3. Now, in general, we can say that B equal to Bij 1 into n is a row matrix of order 1 by n. Now, it can have any number of columns, but it will have only one row. So, it is a row matrix. Now the third type of matrix is square matrix. A square matrix in which the number of rows are equal to the number of columns. Now, if the number of rows and number of columns of a matrix are equal, then it is called a square matrix. In another language, we can say a matrix of order m by n is said to be a square matrix if its number of rows means m and number of columns means n are equal. That is, m is equal to n. And this is named as the square matrix of order m, or you can say the square of matrix of order n. Now, take an example. There is matrix A. It has 3 rows and 3 columns. That means this is a square matrix at number of rows and number of columns are equal, that is 3. So it is a square matrix of order. In general, A equal to Aij m by m is a square matrix of order m. Fourth one is diagonal matrix. A square matrix B equal to Bij m by m is said to be a diagonal matrix if all its non-diagonal elements are 0. That is, a matrix B equal to Bij m by m is said to be diagonal matrix if Bij is equal to 0 when I is not equal to j. That means if row of an element is not equal to column of the element, then the element of the matrix should be equal to 0. Now see here some examples. Now A is equal to 4. Now this is a matrix of order 1 by 1. It has only one element and it can also be called a diagonal matrix. Now B matrix, here it has elements -1, 0, 0, 2. And as we see here, this first element is of row 1, column 1. This one row 1, column 2. This one is row 2, column 1 and row 2, column 2. Now if the row of element is not equal to the column of the element, as here in A12, now row of the element is 1 and column of the element is 2. So these two are not equal, so the element is 0. Here also A21, here row of the element is not equal to the column of the element, so the element will be equal to 0. Now that means it is a diagonal matrix. You can say, in other words, you can say except the elements of diagonal, the other elements are of a matrix are 0, then it is a diagonal matrix. Here in matrix C also, if you see the diagonal, all other elements of the matrix except the diagonal elements are 0. So it is a diagonal matrix. Now this is a diagonal matrix of order 1, this is diagonal matrix of order 2, and this is diagonal matrix of order 3. Now you should keep in mind that diagonal matrix is also a square matrix. Now fifth one is scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That is, a square matrix B equal to Bij m by m is said to be a scalar matrix if Bij is equal to 0 when I is not equal to j, as it was in the case of diagonal matrix, and Bij equal to k when I is equal to j for some constant k. That means a scalar matrix is also a diagonal matrix, but it has one more property, that all its diagonal elements are same. As we see here, now there is matrix A of order 1. It has only one element, that is 3. It can be called as a scalar matrix. Now B, here in matrix B, we have a diagonal, except the diagonal elements, all other elements of a matrix are 0. Therefore it is a diagonal matrix, but the elements of a diagonal are same. When I is equal to j, this is A11, means row of the element is equal to column of the element. In that case, the elements should be equal. Now this is A22, row of the element is equal to the column of the element, and in both the cases the element is same, that is -1 and -1. So it is a scalar matrix. In matrix C, as you see, all the diagonal elements are same, that is 3 here, and except these elements, all the other elements are 0. So it is also a scalar matrix. Now A is a scalar matrix of order 1, this is scalar matrix of order 2, and this one is scalar matrix of order 3. Now sixth one is identity matrix. Now identity matrix is also a scalar matrix. Now a square matrix in which elements in a diagonal are all 1 and rest are all 0 is called an identity matrix. Now this identity matrix is also a scalar matrix, but it has one more property, that all its diagonal elements are equal to 1. In other words, we can say that a matrix A equal to Aij m by m is an identity matrix if Aij is equal to 1. If I is equal to j, that means the diagonal elements are all equal to 1, and 0 if I is not equal to j. That means except the diagonal elements, all the other elements should be equal to 0. We denote the identity matrix of order n by in. Identity matrix is always denoted by I. Some examples of identity matrix are A. It has only one element 1, that is identity matrix. Now matrix B, all its elements are equal to 1 and other elements are 0. So it is an identity matrix of order 2, and C is an identity matrix of order 3. Now, zero matrix. A matrix is said to be zero matrix or null matrix if all of its elements are equal to 0. Now, for example, this A is a zero matrix of order 1, B is a zero matrix of order 2, and C is a zero matrix of order 3. Now, its all elements should be equal to 0, and zero matrix is always denoted by O. Now, equality of matrix. Now, two matrices A equal to Aij and B equal to Bij are said to be equal if these two matrices are of same order and corresponding elements of matrix A and matrix B are equal. That means you can say that Aij is equal to Bij for all I and j. Now, for example, there are two matrices A 1 2 3 4 and B 1 2 3 4. Now, if we see here, the order of the matrix A is 2 by 2. It has 2 rows and 2 columns, and order of matrix B is also 2 by 2. Now, first condition is satisfied that the order should be same. Now, each corresponding element of the matrices should be same. Now, this one is A11, means element of row 1 and column 1, and here AB11 means element of matrix B of row 1 and column 1 are same. Similarly, the element of row 2 and column 2 is same in both the cases. Third element, that is of row 2 and column 1, is also same in both the matrices, and fourth element, that is of row 2 and column 2, is same in both the cases. So, if all the corresponding elements of two matrices are same, then these are the, you can say, equal matrices, and we can say that matrix A is equal to matrix B. Come to the exercise 3.1. In first question, a matrix A is given to us, and we have to find the order of the matrix, the number of elements, and the elements A13, A21, A33, A24, and A23. Now, first one is order of a matrix. Now, order of a matrix. In this matrix, there are 3 rows: 1 row, second row, and third row. 3 rows, and there are 1, 2, 3, 4 columns. So, its order will be 3 by 4. Now, number of elements in the matrix will be equal to number of rows into number of columns, that will be 3 into 4, and that will be 12. Now, we have to find the element 1, 3. Now, element which is common in row 1 and column 3. Now, row 1 is 2, 5, 19, minus 7, and column 3 is 1, 2, 3, 19, 5 by 2, and minus 5. And the common element of row 1 and column 3, row 1 and column 3 is 19. So, this will be equal to 19. Now, after this, A21, element of row 2 and column 1. Now, row 2 is this one and column 1 is this one, and the common element is 35, so it will be equal to 35. Similarly, we can find the other elements. Now, A23 means row 2 and column 3. Now, common element of row 2 and column 3 is 5 by 2. Therefore, the element A23 will be 5 by 2. Now, question number 2 and 3 are same. In question number 2, it is saying if a matrix has 24 elements, what are the possible orders it can have? What if it has 13 elements? Now, if the matrix has 24 elements, now we can write the multiples of 24, as we can take a row matrix of row 1. If row is 1, then column should be 24, so that their multiple is equal to 24. Now, if we are taking 2 rows, then number of columns should be 12, so that their multiple is equal to the total number of elements, that is 24. Similarly, we can take 3 rows and 8 columns. 4 rows and 6 columns. We can't take 5 rows because 24 is not a multiple of 5. So we are taking 6 rows, 4 columns, and so on. We can proceed up to 24 rows and 1 column. Now similarly, another part of the question was, if a matrix has 13 elements, then what are its possible order? As you know, 1 by 13. Now we can take a row matrix, so there should be 13 columns, so that their multiple is equal to 13. Now there 13 is a prime number, so it has only two multiples, that is, only two factors, that is 1 and 13. So another will be 13 by 1. Now see question number 4. We have to construct a 2 by 2 matrix A equal to Aij, whose elements are given by Aij equal to I plus j upon 2, I plus j square upon 2, and second one is Aij equal to I upon j, and third one is Aij equal to I plus 2j square upon 2. Now I am doing first part of it. Now we have to construct a 2 by 2 matrix, therefore we are taking a matrix A of order 2 by 2. Now its first element will be A11, second will be A12, then A21, A22. The first number represents the row of an element. Now this is row 1, so first element is 1. This is row 2, so the first element we have taken as 2. Now second element represents the column of a matrix. Now this one is first column, so second element is 1 1, and this one is second column, so second element is 2 2. Now we will put these values of I and j in the given equation. Now what will be element A11? Now as we see, the equation given to us is Aij. Here it is Aij equal to I plus j square upon 2. So this will be I is 1 and j is 1. So I plus j square upon 2. Similarly, A12 will be I plus j square upon 2. I is 1 and j is 2. Here I is 2 and j is 1. And here I is 2 and j is also 2. Now this will give us, now 1 plus 1 will be 2, square of 2 upon 2, and that will be 2. Here it will be square of 3 will be 9 by 2, and here square of 3 will be 9 by 2, and square of 4 is 16 by 2, and that is 8. So we can write that this matrix A is, now element, what is element A11? That was 2. Element A12 was 9 by 2. Element A21 is also 9 by 2. And element A22 is 8. In this way, we can solve the other parts of question number 4th and also the question number 5th. Now in question number 6th, we have to find the value of x, y and z from the following equations. Now first one is, now he is also saying that these matrices are equal. The sign of equal is given to you. Now 4 3 xy x5, and second matrix is yz 1 5. So as you know, in equal matrix the corresponding elements should be equal. So that means 4 will be equal to y, 3 will be equal to z, x will be equal to 1, and 5 is equal to 5. So values of x is 1, y is 4, and z is 3. Similarly in second also you can say x plus y is equal to 6, 5 plus z will be equal to 5, and from this we can get the value of z. Now xy equal to 8. Now we can solve this x plus y equal to 6 and xy equal to 8, and then find out the value of the matrix of x and y. In last part, this is x plus y plus z equal to 9, x plus z equal to 5, and y plus z equal to 7. Now we we can subtract the equation second by first to get the value of y, and equation third by first to get the value of x, because y z will cancel out, and then put the value of y and x that we have obtained in equation first to get the value of z. Now in this case here it is x plus y equal to 6 and xy equal to 8. Here the second part of question number 6, I have solved it. Now x plus y equal to 6, 5 plus z equal to 5, and from that we are getting z equal to 0. xy is 8, xy equal to 8. Now here x plus y and xy is given to us, so we can find the value of x minus y from the formula x minus y square equal to x plus y whole square minus 4xy. Now value of x plus y was 6 and value of xy is 8. Now from this we are getting x minus y whole square is 4, and that will give us x minus y equal to plus minus 2. Now if we take the positive sign, then it will give us x minus y equal to 2. This I have taken as equation 4th, or we can take the negative sign and this will give us x minus y equal to minus 2. Now we'll solve first and fourth equation and then first and fifth equation. Now if we solve this first and fourth equation, we are by elimination method we are adding these two equations. On adding first and fourth we are getting the value of x is 4, and again on putting the value of x equal to 4 in equation first we are getting the value of y as 2. Again on solving equation first and fifth equation we are getting x equal to, on adding first and fifth we are getting x equal to 2, and again from equation first if x is 2 y will be equal to 4. We are getting two values in this values of x and y. Now here in first case x was 4 then y was 2, and if x was 2 then y was 4, and z is 0 in both the cases. So we can say the value of x is 4, y equal to 2, or z is 0, and in second case x is 2, y is 4, and z equal to 0. Seventh question. In seventh question we have to find the values of a, b, c and d for the given equations. So we can solve this one. A minus b equal to minus 1, 2a plus c equal to 5, 2a minus b is 0, and 3c plus d equal to 13. So we are getting the four equations in this case, but as we see the first and third equation are in the form of a and b, so we can solve both of these to get the value of a and b, and then put the values of a in this second equation, and then we can find the value of c, which on putting in fourth equation we will get the value of d. Now eighth question is a ij m by n is a square matrix if. Now as we know, in case of a square matrix the number of rows is equal to number of columns, that is m is equal to n. Now again in question number 9th we have to find out the values of x and y which makes these two matrices equal. Now two matrices in question number 2 matrices are given equal. He is saying that you have to find the values of x and y if these two matrices are equal. Now in the first element of first row is 3x plus 7, and here the first element of first row is 0. These two will be equal. In order that these matrices are equal, so their elements, corresponding elements should be equal. Now from this we are getting the value of x as minus 7 by 3, and second 5 will be equal to y minus 2, and from this we are getting the value of y is 7. Again here y plus 1 is 8, the value of y is again 7. Now here 2 minus 3x equal to 4, and that is giving the value of x as minus 2 by 3. So what we are seeing here, that for the value of y we are getting the same values, that is not a problem. Value of y is 7, here is also value of y is 7. But if you see here, from the first elements we are getting the value of x as minus 7 by 3, and here from this last element of the last row of both the matrices we are getting the value of x as minus 2 by 3. That means these matrices are not equal, and we can say that if these matrices are not equal, that means the values are not possible to find. Now in question number 10th, the number of all possible matrices of order 3 by 3 with each entry 0 or 1. Now we have to find the possible matrix of order 3 by 3 with each entry 0 or 1. How many matrices will be there? Now order of matrix is given to as 3 by 3. So the number of elements will be equal to 3 into 3, that will be 9. Now he is saying that you have to fill these matrices with only two entries, that are 0 or 1. We have only two numbers which we can enter. Now how many possible matrices will be there? Now you have to fill the 9 places with only two numbers, that are 0 or 1. So the number of possible orders will be 2 raised to power 9, and that will be equal to 512. So these we can make 512 matrices with the possibilities as 0 and 1, and the matrix should be of 3 by 3 order. Thank you.